Hi, welcome back to this channel. In this video, we are going to discuss a few questions related with the chapter Reaction Kinetics, Thermochemistry, and also Electrochemistry. Let's start with question number 1. The rate law for the reaction A produced product is given as rate equal to K concentration A. So at here, we can consider that rate equal to K to the concentration of A power of 1. The unit of the rate constant is, so the unit for rate is molar per second. The rate constant we have no idea yet. And then the concentration of A, the unit for concentration of A is molar with the power of 1. So then from here we just move the molar to the left hand side. So it become molar per second over molar. So molar and molar cancel out, so the unit for rate constant is per second. Question 2. The rate law for a reaction is rate equal to K concentration A to the power of 1 again, with the value of rate constant 0.741 per minute. What is the half-life of the reactant A? So from here we know that the reaction is first order. So the formula of half-life for first order is ln 2 over K. So we substitute the value of K into the formula, which is 0.741 per minute. So press the calculator, you will get the answer 0.935 minute. So A. Question 3. Consider the following reaction. What is the rate of the disappearance of B if the rate of disappearance of A is 2.6 exponent negative 2 molar per second? Once we look at the term rate of disappearance, so basically we know we need to write down the differentiate rate law, which is rate equal to negative d concentration A over dt, and then equal to negative d concentration B over 2 dt, because the coefficient of 2 for the B. Okay, so if since this is objective question, so if you didn't write complete for the C and D, then it's okay. So then from here we have the relationship between the A and B. So we can just move down here. Write this appearance of the rate of reaction for the reactant A and the reactant B are the same. However, they have different rate of disappearance. So now we want to look for the rate of disappearance of B. As usual, we will put the rate of disappearance of B at the left hand side, and then equal to negative rate of disappearance of A. So given that the rate of reappearance of A is 2.6 exponent negative 2 molar per second, but then don't forget, if we're looking for the rate of disappearance, it is always without the coefficient. So that's why we will adjust it, become negative d concentration B over dt. So from here is over, move to this side, will become multiply. So will equal to 2.6 exponent negative 2 molar per second times 2, which will equal to 5.2 exponent negative 2 molar per second. So the answer is donkey. Question 4. Which of the following is the integrated rate law for first order? So as we already always remember the formula for the first order always involve the ln. So among all these 4 options, only option B is involved the ln, so the answer is B. Question number 5. Given the rate law, rate equal to K concentration A to the power of 2 and concentration B basically is power of 1. So determine the reaction order to each reactant and also overall reactant. So if we want to determine the order for each reactor, we just focus on the power here. So for reactant A, the order is 2. So option A and donkey will be out. And then for reactant B, the order of reaction is 1. Okay, so how to get the overall reaction order? We just total up the order for A and also the order for B, which is equal to 3 third order. So answer is C. Number 6. Which of the following equation represent the enthalpy of atomization for calcium? So roughly recall back the definition for enthalpy of atomization is 1 mole gaseous atom formed from its element, So because of the keyword here is atom, so it's the product. So when we're looking at the option A until D, we have the idea that B, C, and D will not be the answer because all the Ca2 plus are represent ion. Okay, then maybe we still can double check. So gases, atom formed from its element. Calcium is the metal, so always in monoatomic atom and with the physical state of solid. So the answer is A. Question 7, we are given a thermochemical equation. What is the enthalpy change for the formation of 1 mole of SO3? So from here we need to find the enthalpy change, means that we need to get this value. And then we want to know about SO3. So we will compare the SO3 with the enthalpy change. So from the above equation, 2 mole of SO3 is formed and then will release negative 198 kilojoule. Okay, so this one is formed, which is similar as here. Okay, then next one is how about if 1 mole of SO3? So from here we can use the crossover multiplication. So press the calculator, negative 198 kilojoule divided by 2, so it's equal to negative 99 kilojoule, which the answer is B. Question 8. Which of the compound has the largest magnitude of the lattice energy? So largest magnitude here we will relate with the attraction force. So if the stronger the attraction force, so the magnitude of the lattice energy will be stronger. So will be larger. So what are the factors that will affect the attraction force? Basically, we can check the ionic charge. It's the first priority. If they have similar ionic charge, then only we check the ionic radius. So now when we look at the option A until D, we are not going to comparing the N ion because all of these N ion are the same. So we're going to compare Na plus, rubidium plus, samsium plus, and potassium plus. So from here we know that all of them are from group 1 element. So if from the group 1 element, we know that if going down the group, the size is getting bigger. So among these 4, sodium is at the top of the group 1. So the ionic radius is the smallest at top. So it's smallest. Then will cause the attraction force stronger and lead to the largest magnitude of the lattice energy. Which of the following have the enthalpy of formation which equal to 0? So basically it's referred to element. Okay, so element means that only consists of one type of atom. So from here, we can see that the option is A. Next question, choose the correct enthalpy based on the energy cycle. So when you are given the energy cycle, so it will be better we always identify the starting point. So from here we know that A is the starting point because more than one arrow coming out from A. And then the ending or the destination is D because more arrow pointed to it. So this is the ending. Then from here, this cycle, we can see there are two rows. So one is from A directly to D. And then another one is from A goes to B, then to C, then only to D. So as we know, according to the Hess law, no matter how many steps that you go through, the energy involved will be the same. So first row is W only. So W equal to X. Second row we need to pass through S and then Y and Z. So that's why the answer is C. Which of the half equation is not true? Means that they are false. Okay, so copper plus gain 1 mole of electron will become copper, correct? Add iron 3 plus gain 2 electron become iron plus, correct? Lead 2 plus gain 1 more electron. Basically, the answer supposedly is lead plus. Magnesium, if lose 2 electron, will become Mg2 plus. So the answer is C. Question 12. What is the product formed at the cathode for the electrolysis of aqueous sodium sulfate solution? So we know that this is aqueous. So beside from Na plus, SO4 2 negative, there will be have water as well. So because of we want to ask for the cathode, so cation will attracted to cathode, which is Na plus, and then at the same time H2O also will attracted to the cathode. So between these two, which one will be the selectively discharged? So from we already learned in the tutorial. So we have know that if we have Na plus and water, water will be selectively discharged. So if water selectively discharged, the product produced, because it is selectively discharged at cathode. So this is the way that we remember. We can see the hydrogen first, the symbol of H first, so it's referred as hydrogen. So the answer is A. So now you are requested to write the Nernst expression based on the half cell. So as we know that Nernst equation is E cell equal to E naught cell minus 0.0592 over N log Q. So the N is referred to number of electron. So here we can see there is 2 electron. So basically option B is out. Then next we will look at the Q. Q is the product over reactant. And then we only will include the aqueous and gas only. So from the half equation here, the product is S negative aqueous and then 2. So that's why the product part will be the concentration of S negative to the power of 2. So option A is okay. Option C is out and then option D also out. So next one, over the reactant. Since the reactant is the gas, so that's why over the partial pressure of the gas. So the correct answer is A. This question gives us the standard electrode potential for M and N, which respectively is positive 0.34 and negative 0.25 volt. Okay, so from here we know that we need to determine which one is anode and then which one is cathode. So as we remember, if the SRP value more positive, means that they tend to gain electron. If tend to gain electron, means that undergo reduction, and reduction always happen at the cathode. So then from here we have the idea that this M will act as cathode. Okay, so cathode is always referred to the solid. So option A and D will be out. Since M is the cathode, so N will be the anode. So the answer is B. So now we need to calculate the standard cell potential for this galvanic cell. So if we want to calculate the standard cell potential, E naught cell equal to kakak tolak adik E naught cathode minus E naught anode. So just now we already have idea that the more positive one will be the cathode, and the more negative one will be the anode. So will be positive 0.34 minus negative 2.37. So press the calculator, you will get the answer is positive 2.71 volt. So answer is A. Second last question, you need to calculate the electrical charge in column can be produced by supplying 0.2 ampere and 16 minutes for the molten barium chloride. Okay, just recall back, if molten, the physical state is liquid. Okay, so if we want to find the unit, the electrical charge in the unit of coulomb, means that we're going to use the formula Q equal to IT. I is 0.2 ampere, and then the time must be in the unit of seconds. But the question gives us in minute, so we're going to use 60 multiplied with 60 because 1 minute have 60 seconds. So press the calculator, you will get the answer is 192 coulomb, so the option is D. Okay, we already reached the last question for this video. The reduction electrode potential is given in this table, and then you need to identify the strongest oxidizing agent. As we know, oxidizing agent itself will undergo reduction. Reduction is a process at where need to gain electron, and this lead to SRP value should be more positive. So now here we look at among all these three values, positive 1.36 is the most positive. So means that B and C is out. Then now again, because of oxidizing agent undergo reduction, so means that the reaction is from the left to the right. So the option, the species X2, which is the option D, will be the answer. Okay, class, thank you for your time. I hope you can score better than Chemipedia in your UPS 1.